Welcome to Sierra Club Monthly Science Monday program. My name is Steve Miller. Mary Riley and I are your co-hosts tonight. We are now announcing our programs on Instagram. Please add a note in chat if Instagram enticed you to attend. John and Diane Burke tonight are going to describe the design of their passive house that is soon to be constructed in the Atlantic Highlands portion of Middletown, my hometown. This is the culmination of their 10-year dream to build a passive house in order to do their part to stop polluting the earth and halt global heating and climate change. John Burke is a professor of economics and finance at Monmouth University. John is excited about the chance to build a passive house, run a small organic farm, and do his part to sustain the environment for humanity's future. And Diane Burke is an evangelist for the earth and halting climate change. Diane is looking forward to her new house, which will leave no carbon footprint. You will hear that John and Diane are committed to halt their greenhouse gas emissions. So after the Q&A, we give you an easy way to halt your greenhouse gas emissions by writing a letter to President Biden. We invite you to submit your questions via chat as they come up, and we will monitor and collect questions for handling at the end of John and Diane's presentation. So John and Diane, the floor is now yours.
A social responsibility to do whatever we can do to help future generations on this earth. And when we came across this passive house and we went and visited, I don't know, probably half a dozen of them, they were just really amazing, innovative ways to start building new houses. And we thought this would be a great way to have some sort of self-responsibility. You know, we did a lot of, activism for stopping pipelines and going to DC for protests. And that's big and global, but that's changing politics and changing big stuff. But what could we do for us, just individually? So it was like just something that we really wanted to do, mostly for climate change. But when we went to visit these houses, the ambience of the home was just beautiful. The air was so clean and fresh, and also so quiet, because basically it's a house like a thermos. It's really, really insulated. And we chose to do prefab instead of stick build because of it doesn't generate a lot of waste. It's just part of the whole, footprint is to, make a house without having a lot of waste. And so all of that. And then the cost was a consideration for a long time, but actually the cost is a little bit more money, but it's not that much more expensive than a stick-built house. The obstacles that we had to make this house, and that's why it took 10 years, was the biggest part was finding a property. We wanted to find a property that didn't have, a grand, perfect house that was brand new. We needed a house that was old, that we didn't mind knocking down. And we also wanted property so that we could build an organic farm and have that part of the whole thing. And the next obstacle was really doing a lot of research on different prefab housing companies. There are quite a few of them now, a lot in New England, and that took quite some time also. And lastly, what we're going through now is trying to get a variance in Middletown and getting the permits and all of that stuff. We're trying to live in the existing house and build the house and then just move over, rather than move out of here, knock down the house, rent a house and all that. It's causing a little bit of a problem also and slowing us down. But those are basically the major obstacles.
So those are our goals. How do we want to achieve them? There's a couple ways. The big way is to minimize thermal bridges. That's basically how heat wants to move. And we know the laws of thermodynamics. Heat will seek cold. So in the winter, the heat's going to escape from your house. In the summer, the heat's going to get into your house. And so minimizing thermal bridges will keep that to a minimum. Insulation is going to be really thick. 8-inch walls, 8-inch thick walls, instead of 6-inch, which is typical on a house
18-inch.
it will be 18-inch instead of 6 inches, which is typical in a house around here. There's a cool system called an energy recovery ventilation system, ERV, and that really works well with a passive house. So it really recaptures the heat within your house in the winter and the cool within your house in the summer while it's bringing fresh air into the house. Also, instead of the typical furnace, we're going to use a high efficiency heat pump, which generates heat through compression and cooling through expansion. So that's a pretty cool technology. And the windows are really interesting. They're triple pane instead of double pane, which you usually see. And lastly, we want to make sure all our appliances and lights are as efficient as possible. So talking about the thermal bridges, this is a little graphic that kind of shows you how that works. Typical house might lose 35% through the walls, 25% through the roof, so on and so forth, doors, windows, cracks.
Here's an example of thermal bridging with this thermal image. And you can see the passive house in the middle, it's dark. And those houses that all the heat that's escaped through windows and doors, it's just an incredible amount of energy that's lost. So you can just see the obvious difference between the passive house and the normal other houses from the old days.
Is it that the redder it is, the more heat is coming out, and the bluer it is, the less heat?
Yes.
Yes, thermal imaging is picking up the heat.
So you could see with any house, if you had like thermal imaging, that's what just any house would look like. That much energy is being escaped.
Or maybe these people just went to Florida for the winter. I don't know. So the building envelope. So here, the orange area is the insulation, which I mentioned is 3 times as thick as a normal house everywhere. And then the little red line going throughout the whole thing is the thermal barrier. And it's an airtight barrier. So it's like a balloon, kind of encasing the whole house in a balloon. So the only way air is going to get in and out of the house is where we want it to, through the heat exchanger. So it's a really efficient combination of using an ERV with the thermal barrier. As we were getting into this stuff, we kept being bombarded by all these buzzwords, R values, ACH, Pascals, we didn't know what they were. So Google helped us a lot, but we'll share some of those with you. So R values are basically talking about thermal resistance. So it's how easily or difficultly heat will be transferred through a material. The higher the R value, the better insulator that material is. So for an average house, here's the R values for the walls, roofs, foundation, and windows. And then passive standard is here in the middle. And the percent improvement is 100 to 300% better for the passive house. So that's a big step up. And then this is even bigger. So the blower door test, we want the house to be airtight. So all the air is coming in and out through the ERV only. And the way they do that, and here's another buzzword, is to achieve the passive house standard of 0.6 ACH at 50 PA. Well, what the heck is that? So ACH is air changes per hour, and 50 pascals is a measure of pressure. So what happens is they put this device on the door of the house and everything else is closed, and the fan blows air into the house, and then this device measures the pressure within the house. So they want to get the pressure to about 50 pascals, which is not very much, 0.07 pounds per square inch. So once that thing's going, the average house will have about 25 to 33 air changes per hour. So that's quite a bit. The passive house standard is less than 1, 0.6. So that's about a 4,000 to 5,000% improvement over the average house. So that's a big deal. And then here is, combining that with the ERV works great. So here's how the energy recovery ventilation system works. Basically, in the winter, we've got warm air in the house and we've got cold air outside, but the air in the house is stale and we'd like to get fresh air. So if we bring the cold air into the house, it's going to cool off the house unless we put it through a heat exchanger. So what happens here is the warm air goes through the heat exchanger, heating up the cool air as it comes into the house. So it recaptures about 85% of the heat. And then it works the opposite way in the summer. We want to keep the cold in and the heat out, but we want to get fresh air, and it works the other way. So it's really a beautiful system.
The windows are also a big part of the passive house. And as you can see, it's a triple pane. So normally windows have 2 panes. So you have that one area of insulation with the air between. But with triple pane, you get twice as much insulation. And then how it's built, so bulky, it really keeps the thermal bridge closed from escaping from the windows. The other cool thing is because it's so insulated, you really don't hear any noise from the outside. You won't hear traffic or anything. And then the windows operate by both tilting sideways, like I don't know, perpendicular,
Like
and then also up and down.
You go like that.
Yeah, so both ways. So that's a big part of the passive house. And then the goals we had for our design, this is our forever house. So we're 63 years old and we basically want to stay here until we die. So we thought we better have the master bedroom downstairs because you never know what's going to happen. And then also the laundry room is in the mud room, and we wanted a dog wash because we always have 2 crazy dogs that go running with me and they're always muddy. So to make it easy and keep them clean, we have a dog wash. So these are like different wish lists. We love natural light, so we wanted a lot of windows. So that's totally possible with a passive house. You don't have to be like the Flintstones and just like, you know, darkness. And then we also like a lot of open space instead of really small rooms everywhere. So that was a big part of our decisions and how we designed our house. Then we also cared about going beyond passive, which it's passive just in the design of the architecture, but solar panels help to, you know, give the energy for the dishwashers and the lights and all that stuff. So,
so Diane, not everyone may know what passive solar is. You may want to explain that just a little bit.
So the passive house, passive house is the architecture of the passive house itself creates a situation where you have basically a very low carbon footprint because of the insulation and all of that. But when you add solar panels to the house and you orient it south, now you can actually be like carbon positive if we were allowed to do that. Although right now we're not allowed to do that. But so we have this, we're orienting the house towards the south. We're putting solar panels up to take care of all of the electric things and appliances in our house. And also we have an electric car, so it can help the electric car, you know, fuel the electric car. And we're getting an electric pickup truck also, Ford, right?
Yeah. Two things on that. One, Diane said we can't generate more power than we use. I mean, we can, you know, month to month. Some months maybe we'll use some power from the grid. Other months we'll generate more than we use. The idea, though, is over the course of a year to be net neutral. The rules are, though, if you generate 5% more than you use, so 105% of what you use, you could be regulated like a utility, which we do not want. So we got to size the thing right. And Diane mentioned the truck. Yeah, a friend of mine the other day said, "Hey John, who's a good Ford dealer around here? Because I want to buy one of the new Ford electric pickups." And I was like, "Oh, that's interesting." So I, told him a dealer, and then I looked at it myself. And you can get one of these F-150 pickups, all electric, with 700 foot-pounds of torque, 500 horsepower. The base model is $41,000. You get a $7,500 tax credit. And if the new bill, the green bill, goes through Congress, they'll increase that by $4,500. So 41,000 minus 12 grand, basically your net cost is 29,000. That's pretty attractive. And what's cool about it is you can run your house off the truck for 3 days if you have a power outage, or take the truck out in a field somewhere and plug things in. So pretty cool. We're in.
Yeah. So this is a picture of our house. This is what our house will look like. The blueprints are ready. We're submitting it to the town to get permits. So this is it.
Except we changed the color to blue, I think.
Yeah, it's not going to be white. Here's a real house that's already built. It's in Lumberton. We went to visit it. The people were so nice. We went in. Again, the ambience, I can't tell you how much, like, it's just feels so good to be in the house. The cleanliness, the air is so clean. And you don't feel like forced air or hot or dry or anything. It's like just perfect air.
Yeah, no dust.
Yeah. Here's another model, a different model, same company, Unity. It's just a different model. There's a new one of this model is the Varm in Pittstown, New Jersey, that we went to visit. And so in addition to living in this dwelling, a big part of climate change is also is big agriculture, you know, how we're doing agriculture and the footprint of food. You know, we get food from Costa Rica and even California. That's a long way, a big carbon footprint. So we just want to be aligned in as many ways as we can to minimize our carbon footprint. So we built a big organic garden, and we're trying, and in New Jersey, I've been getting lettuce from March, and now I have new lettuce coming, and I'll have lettuce till after Thanksgiving, you know. So it's a really big growing season to get your own food. We also plan to get some sheep and maybe goats, maybe alpaca. You know, the manure that they produce is so good for the vegetable garden, and also just bringing more life and to the land that we have here. We have bees, and we planted 5 acres of Dutch white clover because it's like the best flower for bees. And so they produce, how many gallons of honey did we get last year?
We made 633 pounds of honey last year, and some beeswax too.
Right. And clover planted in your lawns helps to put nitrogen in the lawn instead of using, you know, fertilizers that go down into the sewers. And then we plan to harvest the water off the roof. People talk about wells, but wells are still sucking the aquifer, you know, and the water from the, you know, reservoir is taking water, you know. So water from the roof oftentimes runs down the driveway into the sewer and into the river. It's lost, that fresh water is lost. So we want to harvest that water and put it into our, you know, landscaping, gardens, so that can go back into the aquifer from the ground. So that's a part of the, you know, the carbon footprint too. So here's what our tennis court looked like. A lot of weed trees exploding through the asphalt, cracks everywhere. I don't think anyone played tennis here since like 1972, but we love the fence here because it protected the tennis court from deer. We have a lot of deer here. So we kept the fence up and we took the asphalt out, and I'm excited that we're going to be moving forward towards the vegetable garden. So there's the asphalt down. We put topsoil down and we mulched the whole tennis court. And then John and I built these raised beds. It was COVID, so we had a lot of time on our hands. We built 18 raised beds. We also did the lasagna method with the raised beds, where we put brown leaves, carbon, twigs at the bottom of the raised bed, so it was less topsoil. And then we top that off with topsoil. So that is a great way to start a garden. Here are half of the raised beds that we made. And then here's just an example of what happened with the first summer, the abundance and the beauty that we brought back to this dilapidated tennis court. There was no life there. And just with the flowers, pollinators came. We had food, a lot of food, the birds, there were hummingbirds and yellow finches because we had a lot of sunflowers. And then we enjoyed having farm to table meals with friends and family. And we plan on the other half of the tennis court to put fruit trees in when we remediate the soil there a little bit more, like another year, I would say. We're going to remediate the soil where the asphalt was and then put some fruit trees there.
Do you know how much of your actual food budget came from your garden?
Well, I haven't had to go to the produce section of a grocery store since probably June. I grew 200 heads of garlic. We had onions, potatoes, squash,
Peppers.
and I'm pretty good at like seeing what I have an abundance of, and I'll just make something with that.
That's the special of the day.
Yes, yeah. So now, like, the great thing is fall is even easier to plant things than spring, even though people seem to be really jazzed about spring gardens. Fall is so much easier because the insects go away, the pests go away. But you can grow so many fall crops. So we have a lot of new lettuce I planted in August. So we have salads every single night now from the garden. Spinach, onions again, kale, chamomile.
Last night we had friends over. We made chile relleno, poblano peppers
chili
from there, stuffed, and
jalapenos,
tomatoes, lots of sauce.
And then we make a lot of crushed red pepper. You cook the cayenne peppers, and I haven't had to buy crushed red pepper. We eat spicy food. Crushed red pepper from McCormick in years, and I give that out for Christmas presents too, because there's an abundance of peppers. Are pretty easy to grow. So yeah, we just try to eat from the garden.
And it's fun. It's interesting. I like it.
Yeah.
So here's a couple of links that we think you might find useful. Unity Homes is the one we ended up choosing. So that's a good place. Benson Wood is basically their parent company. Benson Wood does more custom homes, $1 million plus just for the construction of the home. So we were trying to scale down, not up. So we went with Unity, which is more their pre-planned things, but they have a few different models, probably 4 or 5 different models. And you can mix and match them. You can mirror image them and add a module for a bedroom and things. So it's kind of like Lego. You can click the pieces that they've already designed together in the fashion that you want. EcoCore is another company that's really good. Hard to pick between the two. EcoCore is also really good people, and they also made a really good video that explains the benefit of using a panelized construction. So they build it in a factory. It's all designed on a computer and cut on a computer, and then they bring everything out to your site. And lastly, this is a contact, so it's Diane's email. If you want, stay in touch with us, have any questions anytime. And it might be really cool to come watch the time, and we'll keep, if you send us your email, we'll keep you up on when it's going to be, when all the walls come up, they pop the roof on top. That'll probably be about a week process to get everything up. Then we're going to hire a GC, our own general contractor, to finish the exterior and interior, which will probably take a few months after that. But the basic part of the house will go up in a week or two. So it's pretty quick. And I think that's it.
Right.
So questions.
So Diane and John, this is Amy.
Why,
when you thought about doing the house, when somebody, I guess it was Mary, was talking about passive solar. I mean, there is passive solar, which is for heat, actually. And I've been in Wisconsin. This was like 30 or 40 years ago. A whole town had built everything with passive solar, or used, they had a supermarket where they never turned the gas on because they figured out a way to use the refrigeration heat and everything else to create the heat, and we were there in the heat of summer and it was cold as ice and yet they had no air conditioning on because they were somehow had used really incredible passive solar. So I'm wondering if any of the systems ever consider that, solar attics or other kinds of things.
We don't. I mean, we're just going with the stuff we showed you, which is for heating water, it's going to be the heat pump. So And that runs with electricity, which will come from our solar array from the photovoltaic. But there's other passive solar stuff too. And I see if I can back up here somehow. Where is it? It's the one with my bridges, this one. This is an interesting thing here. So in the summer, the sun is high, and these houses are often designed with things like that in mind. So we don't want we want it cool inside. So we don't want the sun beating on the floor. But in the winter, when the sun's low, we do want it. So there'll be like a little overhang there. So that'll allow, prevent the sun from coming in the summer, but warming the floor and maybe even the walls in the winter. So that's also passive solar and intelligent design. And, it doesn't cost much to do, but it helps a lot.
Part of the passive house, and I don't know if this is part of passive solar, but the north side of the house oftentimes doesn't have windows.
Yeah, I mean.
And the south side has the windows, right? Isn't that
right? If you want to go crazy, that's you wouldn't have any windows on the north side,
right?
Like we said, we like windows.
Or what
we like windows too.
Yeah, or they put trees there, so it's something's protecting the north side.
And the windows they do have are really small. If you really want to go crazy, the best shape with the most interior space and the least exterior space is a sphere. So if you want to go nuts, make your house a sphere with no windows.
Feel like you're in a boat, right?
But there's people that do that. So you got to draw the line between aesthetics, what you want your environment to be like, and still achieve your goals. So that's what we're shooting for, and I think we'll hit that.
Yeah,
great.
You have questions in chat. One person asked, how do you keep the groundhogs and rabbits from eating the lettuce?
Well, that's the big fence that's around the garden. So right there.
Keep the groundhogs out?
Actually, we dug low and put the fence 3 feet down also. So
chicken wire.
Yeah, so there's chicken wire 3 feet down. So the groundhogs would have to dig deeper than 3 feet. Plus, our dogs kind of convinced the groundhogs that existed here when we moved to seek other housing, so they left. But we were Diane and I were sitting on the patio once enjoying our new house, and like, well, what are we going to do with this ugly tennis court? Sipping a glass of wine, and we said, I know, let's knock it all out, make it a huge garden. It was 60 by 120. Leave the fence, which is 10 feet high, so deer can't jump over it, and it worked great. So we haven't had any animal problems in there, but we have had some insect problems in there.
Yeah.
Doesn't keep the insects out.
Someone
else, Roshini has a question. Yeah, can you turn on your mic, Roshini? There you go.
Hi, my name is pronounced Roshni.
Roshni, hi.
Roshini.
Hi, how are you? My question is, I'm very new to the whole idea of passive homes, so I'm learning a lot. I don't know if I understand it 100%, but that's okay. I think, what this whole project seems really cool, and what both of you have done is really incredible, especially like creating the garden and everything. I have 2 questions. Like, one question is, what do you think have been the biggest challenges in like your advocacy for passive homes? And also, like, how does one find the appropriate property to build a passive home in the first place? I don't know if those are good questions, but that's just what came to my mind. Thank you.
Property, I mean, you could build it anywhere. Anywhere you can build a house, you might as well build it intelligently. So if you're building new construction, it helps to not have trees around it, which you really don't want a lot of trees too much around your house anyways, especially around here, we have trees falling down a lot. The challenges, mostly it was education, like you said, like, I don't know, what is a passive house? And it's not black and white. It really originated from Europe, and now there's a US group that's trying to have it split off, and there's a little conflict between the European and the original European and the US passive house, and they certify your house, and to get the European version is kind of expensive. So we're going to probably build our house to those standards, but we're not going to probably go through all the brain damage and hassle and expense of actually getting it certified by the European group. We're just building it to what we want to achieve, which is the same thing as far as they're concerned, and we're concerned. Diane, other challenges? What do you think?
No,
We'll let you know when the house comes.
the cool thing with a passive house also is it can be a tiny house and it can be a giant McMansion house. It can look like anything. So you don't have to see it as something, it can be whatever you want. And it can be stick built. If you go to Passive House USA and you get in their emails, they have groups where you can go visit passive houses. Like they have passive house tours. And for the last 10 years, we would drive all the way up to New York State somewhere where someone who just finished their passive house was giving tours. So we would go into all these different people's houses, and each time we went there, we would learn more and more and more about it, and then really want to do it because it just felt so good in so many ways. Just again, the ambience, but also I don't know, I'm just going to tell you the truth. When I hear the heat turn on, the forced air heat turn on, all I can think of is someone shoveling coal into the, utility company. And I have a lot of guilt about that. So I've lived really consciously, unfortunately, I think, where it's almost hurtful to me to hear the heat go on, So I just wanted to feel liberated and feel like I am doing the best I can do for future generations in every day, because I'm living in this house, and I just feel like there's a integrity in what my belief system is and then how I'm living. It's aligned.
And I'm doing it in self-defense because Diane's always turning down the thermostat and I'm always freezing.
Yeah. Marco Palladino has his hand raised.
Oh, okay. I can't see it.
Marco, is your hand? There you go.
Well, I was actually going to ask about the trees, because usually people say trees are insulators of your house, but you were kind of saying the opposite.
I used to think that too, till we bought it's an 11-acre property with a lot of trees. We've got like 80-foot trees falling down every time the wind blows. So I've kind of changed my tune on trees personally a little bit. They're nice if they shade your house in the summer and they let the light through in the winter. I understand that, but you don't want them too close to your house within, the length that their height achieves. So you don't want them hitting your house. So yeah, I think that's the trade-off. Yeah.
I was going to ask too about kind of scalability, like for a house versus kind of like an apartment, if you think it's more scalable, because I don't think I've heard passive housing, but not really like for apartment buildings or larger complexes.
We went and visited a sort of like a brownstone, like I think it was a 3-story straight up thing in Brooklyn. It looked a lot like that picture with the infrared thing on it, and it might have even been that.
They retrofitted it,
and they retrofitted an existing brownstone, so it was just that one thing, and it came out beautifully. And I know there has been, some bigger projects where people are building entire apartment complexes, or even in Ithaca, New York, there's a whole community of passive homes. So it's not just one home, it's a whole planned community that way. So, there's a lot more that's being done that way. And I hope and I expect that it will continue to be that way in the future. So yeah, I mean, an apartment owner, whoever the owner is, would be the person to do that. The brownstone, I think, was a co-op, so that's one person's choice. But if it's just like a rental apartment, I think it would be up to the owner to do it.
And if you go to Brooklyn Passive House, I think it's called Brooklyn Passive House, because there's all these different passive house groups. They are doing a lot of retrofitting of old apartment buildings to passive house, because you can retrofit any house to become passive. And then also, if you look up Philadelphia town, planning, I think it was a low income housing passive house complex in Philadelphia that has been built, which makes so much sense, because for low income people, if they are able to live in a passive house, they won't have big utility bills.
One thing an apartment can do is to have land balconies that are really the overhang for summer shielding, but for summer sun, and allow winter sun to come through underneath.
I would love to see Hovnanian and all these big builders start putting in new, when they're taking over huge parcels of land, knocking all the trees down and putting like giant, developments up, that they did it with this intelligence. This would be a wonderful dream come true to see them, changing. And part of our project is to bring awareness to architects, to builders, and to people that are about to build a new home, that this is how they can do it. So we would love to open our house for the next couple of years as a showcase to show the possibilities for builders and architects.
Yeah, and Marco, one last thing, I think to your point, why isn't there more apartments that way and even more houses that way? I think a lot of it has, there could be government incentives. So just like to buy an electric vehicle, we were mentioning the $7,500 incentive that exists currently. But there's nothing for a home explicitly from the government. I mean, there's some energy saving things that add up to a couple $1,000s for some of the things, but as far as bigger tax credits per se, like the thing with EVs, nothing exactly like that. So to build multifamily residences, I think it'd be a great thing for the government federally to get more involved in that kind of stuff.
There's a city in Austria, Vienna. They do a lot of prefab homes, and they're building entire complexes that are, I don't know if they're passive, but they're built with very high environmentally conscious standards. And it's actually, they do it competitively. They make it competitive bids against each other, and the government finances the affordable housing. So it's pretty interesting. I'll post a link.
Great.
There were a series of questions still in the chat that I don't think have been answered. The very last one had to do with a note from Roberta. This type of discussion is 40 years old. Why haven't zoning regulations caught up with this? That's an interesting question. I have a partial answer, actually, that a group of people, 50% by 2030 group, actually met with the Governor Murphy's energy policy advisor. And one of the things she raised with us is that they have been thinking about making energy codes in New Jersey more stringent. And they wanted to know if the municipalities had an appetite for it yet. I don't know if that's yet happened, but California has. And the consultants that New Jersey uses also are consultants for California. And I think that's behind it. There probably is the same consultant saying, hey, why don't you adopt California high efficiency house building code standards in the New Jersey Uniform Building Code? Because, by the way, that's all the municipalities adopt that. And I'd like to see it happen, but that's my answer. Do you have any other answers? Why don't all houses do this now?
What was that, Steve?
The question is of why are we 40 years behind, and why don't we design houses like this now?
I mean, I think for my personal opinion is that builders are just busy building. They're not thinking of a new way to build. There isn't, they're not going back to school. Like, I don't know, some professionals have to, make credits every year to keep learning new, but I think builders, they don't have to do that. And they're just trying to keep up with the housing market. And so there isn't a class teaching them that, and homeowners aren't demanding it. So that's what we're trying to push this.
You know what else? I mean, 40 years ago, fossil fuels were cheap and plentiful, and the concern about the environment wasn't as great. So I think that's another factor really, that's happening now that wasn't as much 40 years ago. I mean, sure, we should have had the foresight then, and I wish we did. But at least, we're starting to move that direction. I see a couple other questions here too. One is Atlantic Highlands. Wait, what was that? Well, it's anyways, it's in Monmouth County, not Atlantic County.
And someone asked how many square feet is our house, and it's 228,
Yeah,
2,800.
2850, about half the size of the house we're moving out of.
And there was another one. Oh, how do you find architects and builders? That's actually a little bit of a difficulty, but you don't really need an architect when you use a prefab house, because that's part of the price. They build, they are the architects. They have architects there, and they work you through the whole process with their architects and with all their people. So you don't need an architect, but you do need a builder. And they have like a team leader when it's time to build the house that teaches any GC how to finish the house, because the prefab goes up and then they basically have to install everything like the plumbing and electricity and drywall and stuff. And so there's always someone there to help them through that. But we actually found a GC who just finished a passive house that worked for Bensonwood, that is part of Unity. So we're probably going to go with an experienced GC from Hillsborough, New Jersey.
Oh, here's another question on air changes per hour. This one is saying that, pointing out or clarifying that in a passive house, the ACH or air changes per hour goes through the ERV. But I think when they first build the house, they want to test how efficient it is. So I think when they're doing the blower door test, the ERV is turned off or closed. So no air is going in and out of it. They're wanting to see how much air escapes elsewhere through cracks and crevices and so on and so forth.
You know, I love that technical drawing that you showed that showed the angle of the sun.
Yeah.
Also showed the heat exchanger, which is a core thing of the house.
Yes.
Right.
Yeah. Yeah. That combined with the air tightness is a great combination.
One of the Marco Palladino asked about passive apartments. I have a condo and I had it insulated. I could change all the windows, but I haven't had the funds for it. But just insulating all the walls, putting I think the same insulation that you have, just makes a huge difference. And the windows are downright rattly, but it's so much warmer and quieter with this. It's really and the passive, on the angle of the sun, I just got, sun's window shades that block out the sun during certain times of the day. Not high tech, but it's been effective.
Yeah, Mary, that's a good point. I mean, the house we're in right now, right here, this is the old house on our property that we bought. And it's from 1967, and a lot of the windows are probably that old. And when we try to close them, there's like little 1/4-inch gaps here or there. But man, when it's cold out, you can feel the wind coming through there. So it's a huge loss of energy through that. So yeah, when things seal tight, that doesn't happen.
Yeah. One thing I'll say though, when it's not windy out, there is not a lot of exchange of air. And in the summer, I have to open the doors because the air doesn't move. I don't have an HVAC system to support that. I've got the old HVAC system. So, it works. Everything is kind of duct tape and bubble gum.
We do too. I mean, we're not going to live with the windows when the weather's nice, which means like kind of between mid 60s to low 80s without a lot of humidity. Our windows are going to be open. We love, right? So we like hearing the birds and all that stuff. But we'll just close them when it's too hot or too cold.
Yeah. Will you be sharing the last slide, especially the last slide, but the deck? Because
sure,
we can't pick the links off when you show it, but we could pick it if we got the deck.
We will share the whole PowerPoint with you guys. Yeah.
Nice.
I think Steve already has it, right, Steve?
I have one from Earth Week.
Oh, it's the same one.
Recent.
Oh, I think it's the same one. We'll give it to you again. But yeah, we'll share it with Steve and Mary so everyone can get it from them.
We can have it distributed.
A way to get to all the people.
Yeah, and then you can click on those links and it should work.
Yeah. And Steve, it's 7:52. Did you want to show people how they could? And by the way, your mic is really low. I don't know if you can turn it up.
I'll just try to speak up. How's this?
That's better. Thanks.
Okay. So we have to try to finalize this. So Diane and John did a super job and continue to do so of reducing their greenhouse emissions and try to zero them out. We have a way that in 5 minutes each of you can take some action to zero out emissions, and that's to write a letter to President Biden to halt new fossil fuel infrastructure, to block it, just like we've been trying to ask the Governor Murphy for the last 2 or 3 years. Every Monday we've been calling him, and it hasn't happened yet. But maybe President Biden would be interested, especially to impress the COP26 meeting in about 2 weeks. This is an outline. It's not the actual letter itself to President Biden, but at the end of this, we will take you to President Biden's letter. But this is an outline. I'm just going to read pieces of it. I call upon your executive authority to declare a climate emergency and to stop fossil fuel projects. Fracking contaminates our water, endangers our health. Plastic plants are equally damaging. All of these fossil fuel projects are pushing our climate to the brink of disaster. President Biden, we must stop supporting fossil fuel through inaction. America is counting on you to stand up now. And the United Nations Climate Conference, that COP26 conference, meets in 2 weeks, and America needs your leadership. So the letter itself, the sign-in for the Sierra Club letter is at this link. I'm going to click on this. If you go to chat, click on that link, the last thing you saw in chat, actsierraclub.org. And President Biden needs your name and who you are. So fill in the information here about yourself. In fact, I'll do it along with you. There's information on the left side. It's going to be sort of duplicated in what follows. So I'm just going to fill in mine so we can time this.
Good.
Okay. And what I'm doing is putting my email and zip code, and I'm actually putting in my home number because I don't want to be bothered by mobile phone spam. Although with Sierra Club, I really do. They have my mobile number. And so once you fill this in, you say continue. And this is the letter. At the bottom of the right is the letter to President Biden. And you can personalize it right here in this box. I encourage you, if you don't want to personalize it, you just go to the bottom and click send your message. It's that's simple and you're done. Or if you want to personalize it, type there what you want. Just go ahead and type in. I'll give you a couple of minutes. And so the left side of this is talking about why all these bad things are happening that deserve to block fossil fuel. And the right side is repeating it, saying we really call on you to stop new fossil fuel projects and declare a climate emergency. So, and then you can personalize the beginning of this. And I've done this with President Biden, and I get a reply back. So you're going to be pleased with the reply. They're going to listen to you. But I hope you're finishing your letter to President Biden. That's your homework for tonight, and you'll be patting yourself on the back and getting a reply back from the White House. So thank you for attending. Any last words from anybody? Is there anything you'd like to raise?
Yeah, I had a few questions. Yes, one of them are the unity houses guaranteed against tornadoes and hurricanes?
I don't think they're guaranteed against tornadoes and hurricanes, but they're built strong, so they're thicker. They're probably sturdier, so I suspect they would hold up better. but doesn't mean you won't get hit by a hurricane.
Well, what I'm seeing in Deal lately is they're building these steel frames,
Yeah.
which I hadn't seen before.
Yeah, I've
in
seen
the
some of those
last.
too.
So I'm wondering if this is going to be as strong.
It's a good question. I'm not sure the answer to that. Yeah, I mean, maybe instead of, within the walls are wood, and it's 18-inch pieces of wood instead of 6. But yeah, maybe they could use steel. Might be a thermal barrier issue because I think wood's a much better insulator than steel. But that's a good question. I don't know the answer to it.
But maybe
So many
they,
interesting questions here.
Most of the steel that's being used now is because wood is just so expensive, in part because of all the fires out west. And so they're actually building steel houses because it's just cheaper and you can't find wood.
Wow.
And when you can, it's just so expensive that it's prohibitive.
the other question I had is this balloon barrier. And now, if you want to put electricity on the outside of your house, that in a regular house, that there's a connection between the inside and the outside. There are conduits. Now, in this case, what happens? Do they have an extra layer for the outside electricity?
That's another good question. Basically, in our planning, we've planned out those. So what you don't want to do is have a general contractor come in and drilling holes through your wall. That would puncture the barrier. So you need to plan it out beforehand, and that's built into the house. So, and I've always believed it's better to have a few extra than not enough. So we put them all around on the outside, but they're designed into the walls right now.
Okay, so there is no conduit between the inside and the outside then?
Yes, there is. It's built in there and designed already in there. But what we don't want is a general contractor coming in later and just drilling a hole through the wall. So it goes through the wall, but it's sealed and insulated, and just the wires are passing through. Same thing for exterior water spigots as well.
Okay, all right. So as long as it's done by the factory, they
Right.
will seal it.
Right.
Okay.
Right. Then they seal all around it, and all that goes through is the conduit
Okay.
for the wires.
All right. Thanks.
There was a question about the air changing of your house. Are you going to be pulling in tiny particles of smoke, for instance, when you have wildfires, less than 2.5 microns? Or is that air filter that's in the circulation system, is that going to be good enough?
Like if you lived in California with all the fires?
Well, we were downwind, of some of the fires. We could.
Yeah, I mean, I think it does filter. I don't know if it filters any better than, an alternative thing. It's probably similar. But you won't get anything else coming through your windows.
Yeah.
But that's a good question.
I'm thinking of the technical
I think
drawing.
it's a very good question, considering we had the smoke from Manitoba, and having lived through the fires in Seattle last summer, it is just terrible what can come through your windows.
Yeah.
So John, the technical drawing actually has a filter that's shown in the air intake for the.
Yeah, there is a filter on the
and you
ERV.
could probably plop in really high potency filters if you choose. If you were in California, for instance. I did put one answer, by the way. There was a question about what is the maximum solar you can have in your house. And that's a question that could be answered by the Sierra Club Home Solar Issues expert, Abbas Salem. I gave his email address. So check your chat and you'll find him. I've talked to him a few times and he's really an expert. So ask your question from him. What size solar can you put on your house?
Question, Diane, could you repeat? You said something about some website that would show you listings of homes and possible tours, something like Passive House.
Right. I don't have the exact website, but if you explore, Google Passive House USA, because they have a convention once a year in New York City, and you can go there and there's vendors for windows, for panels, for stick build, for every aspect of a passive house, for the insulation. And we went and we gathered a lot of material and names, and we signed up for that website. And then they would shoot things like so-and-so just built a house in New York State and they're giving passive house tours. So we just, RSVP'd to that and got the directions and showed up. And so I'm sure that's still out there. We're kind of not doing that anymore because we're kind of doing our own thing at this point. But it was a really good way to kind of get your feet wet to see if it's good for you and to learn more about it, because you go into these houses. Most of the ones we visited were stick built houses. So you could go in when they were halfway built and see, what was going on with the mechanics and everything. But I think you can also call, like EcoCore or Unity and say you're interested. And there are a number of houses that have been built here in New Jersey, and the people are very nice. You could say, I'd really like to visit a passive house. I'm thinking of building one. And they'll probably give you a tour, unless you want to wait for our house, and we'll give you a tour. All right.
Good.
Thank you
All
much
right.
for joining us. And join us again in November. And Mary has an exciting program planned for our next Science Monday in November.
Yep.
Thank you, everyone.
Thank
Thanks
you
so much,
Thank you
Diane.
so
It's
much.
wonderful.
you.
Thank you, John.
All right.
Good to see
Bye, guys.
you.
Thank you,
Good
everybody.
to see you too.
Good night, everybody.
All right, be well.